The first two questions are asking you to classify this based off of what? By its sides and its angles, right? So that means it needs two names, not just one name, two names. The quiz is going to be the same thing where it's asking you to classify on its sides, by its sides and its angles. So if you look at this first one and you wanted to classify number 1 by the sides, does it show you any sides that are congruent to each other? No. So right away, what name would we call it based off of its sides? Scalene, right?
Wait, it's not a right triangle?
Well, that's based off of its angles. It's asking for both names. You got to say both. So yes, it's scalene is based off of its angles, its sides. And then yes, it's a right triangle because it has a right angle. So we would put the angle measurement name first and the side length name second. So we would call this a right scalene triangle. Okay, it's a right scalene. All right, the second one, if you look at the sides, it shows you two sides are the same, right? So if two sides are the same, we call it an isosceles. And then if we look at the angles, are there any right angles that they're showing you? No. Are there any obtuse angles? No. So this is what? An acute isosceles triangle, right? All right. Now we get into the math, and the math is where we're going to have a lot of questions like this where we need to know how to solve for x and know what we're doing. So the first question when we're solving for x, right away, do you see that they're giving you that this angle, not angle measurement, this side and this side are equal, right? What do we know about the angles? If we know that two sides of a triangle are equal, we know something about its angles. What do we know? The base angles are the same. Not all three angles, but two of the two base angles. The two base angles would be this angle right here and this angle right here, right? They're going to be equal. Now, they gave me a clue. They didn't tell me specifically what this angle here equals, but they gave me a clue. What did they tell me about what that angle right there is equal to? It doesn't say x, it says 3x plus. So doesn't that mean that this is also going to be 3x plus 20? And if you add the three angle measurements, what are they going to have to equal? 180. So if the top angle measurement is 4x, and then the left angle measurement is 3x plus 20, and the right angle is also 3x plus 20, if I add these all together, they should equal 180. That would be my equation. Now, we have a lot of like terms that need to be combined, right? We're going to say 4x plus 3x is going to give me 10x. And then 20 plus 30 is going to, 20 plus 20 is going to give me plus 40, right? And now I solve for x by subtracting 40 on both sides. Dividing by 10 on both sides. What does x equal? And there we go. That's how we would find x there, right? Okay. I'm not going to do every single question. I am going to post the answer key so you could check, but I'm going to do every type of question. But you'll see some of the questions are very similar, so we're not going to do every single one. But number 4 is not similar to number 3, so we will do that one. You always want to think about what you are given. If you think about the proofs that I told you we aren't going to do a lot of, but if you remember, what did a proof always start with? Something that's given to you, right? So you're always going to look at what's being given to you. All right. Are they giving you any side lengths here? Any information on the side lengths? No, they're only giving you information on angles here, right? What would you call this angle right there? I heard someone say it, the exterior angle, right? Now, there's a theorem we learned that said something about that exterior angle, something that we need to know to be able to solve a question like this. What does it say about the exterior angle? No clues? That's not good. On the test tomorrow, you're going to need to know about the exterior angle. The exterior angle is equal to what? The sum of those two interior non-adjacent angles. So what that means is this angle measurement, which says 5x plus 7, is going to be equal to the sum of these two angles. And they tell me clues about those two angles. This angle here is x plus 15. And the other angle is 6x minus 26. And if I put a plus sign, that means I'm adding them. The sum of those is equal to that exterior angle. Solve for x. So I'm going to combine my like terms over here. X plus 6x is 7x. 15 minus 26 is going to give me negative 11. The other side says this, and we're solving for x. I'm solving the equation somewhat quickly because at this point, this is kind of just basic algebra. If you look at number 5 is very similar to number 3. Do you agree? So I'm going to help you set it up, but I'm not going to actually solve the whole thing to save some time. So they're giving you angle measurements. They're not giving you side lengths. They're giving you angle measurements. The angle measurement that they actually give you is that right angle, which is 90. The other two angle measurements, they don't give you exact answers. They give you clues, right? They give you an expression. So my equation, I would say, okay, well, this angle, which I know is 90, plus this angle right here, which they're telling me is 3x minus 14, plus this angle right here. What do we do with the right here with this expression? Which is called distributive property, right? So 2 times 3x is 6x, right? So plus 6x, and then 2 times negative 6 is negative 12. And doesn't all of that have to equal 180 because it's a triangle, and triangles, the three measurements, angle measurements add up to 180, right? And then we would solve for x. I'm not going to solve for x, but that's how you would do it. Yes?
I think 6x minus 12 plus 3x minus 14 equals 9.
That works too, because if you do it that way, then you automatically said, okay, this one's 90, which means the other two added together equal 90. That's fine. That works as well. All right. Number 6 is very simple, and it's similar. I'm not going to do that. It would be 90 plus 61 plus whatever x is 180, right? 7, what question is number 7 basically the same as? 4, right? 4 and 7 are the same type of question, so I'm not going to do that one either. If I wanted to set it up properly, I would say that this exterior angle, which is 4x minus 18, is equal to the sum of these two interior non-adjacent angles. So it would be equal to this angle which says 2x plus 6 plus the other angle which says 36. And I would solve for x, right? All right, number 8 is similar to some of the other questions. I'm not going to do that one again. You could check my answer key later, and you'll be able to check your answers to see if it's right. All right. Oops, wrong way. All right. On a question like this, if they're asking you to write a congruency statement, that means you need to identify what's congruent to what. So they've already put the markings on it for you, but if they didn't, I would say color code it. And I would suggest tomorrow that you bring some color pencils or some markers or something to help you color code, because you will be using paper and you won't be able to have your iPad to use different colors. So you could see A, since it's the first letter, and E is the first letter, and you can see they both have the 4 little scoop marks. So A and E, so angle A is congruent to angle E, right? Remember, a figure or a polygon is always made up of angles and sides. So we're first talking about the angles. All right, B and F are next. So those are congruent, and they both have the 1 little scoop mark. So angle B, we would say, is congruent to angle F. All right, next we would say C and G, right? So angle C is congruent to angle G. And then lastly, the angles we would say would be D and H, right? Angle D is congruent to angle H. Now, that's just the angles. What else do we have to talk about? We can't just say the angles are congruent. We also have to talk about the what? What else is this made up of? It's not just made up of angles. It's made up of angles and sides. So let's think about this. AB, doesn't it start with red and end in blue using the colors I use? So AB, we would say is congruent to, well, the other one that starts with red and ends in blue would be EF, right? All right, the next thing would say BC, which is blue to green, would be what, FG? So we would keep doing this for all of them. I'm going to do it quickly, but we just match up everything that matches up. Then I'd have CD, which looks like green to black, which would be GH. And lastly, DA, which is the black dot to the red dot, which would be HE. All right, now, the last thing we would say, they're asking to write another congruency statement. So they want you to write it in a different order than you see there. As long as everything matches up, you're good. So I'm going to just say DCBA. If I match everything up properly, then that would be HGFE. Okay? You could write it different ways, but any congruency statement, as long as each piece is congruent to what it's supposed to be congruent
Any
to.
multiple choice, or would you have to write all of those?
They would probably only ask you, they'd probably say like angle C is congruent to what? Okay? Or, yeah, that might be multiple choice, but they probably wouldn't make you write every single one of those. All right, let's get back into the math, which is more honestly important. So, no, you're good. All right. They're telling you triangle LMN is congruent to triangle RST. So I'm going to color code this right away. So L is first and R is first. So this point and this point are congruent, or that angle and the other angle. L and R are congruent, right? Then the next thing that's congruent would be M and S. So M and S, and then lastly N and T, right? Okay. So they want us to find X and they want us to find Y. Remember I told you if you're given an expression that has two variables in it, are you able to solve for either one of those variables right now when there's two different variables in it? No. So I'm going to start with the expression that only has one variable, which would be this one that says 3x, right? Make sure you're not confusing the difference between angle measurements and sides. This 3x is talking about angle R, and you can see there's a little degree symbol. This 3x plus y is not an angle measurement. That's a side length. That's the length of that side right there. So there's a difference. But let's look at the one that says 3x. Okay? Isn't that going to be congruent to angle L because they're both with the red dot, right? Now, if you look at M and S, they're congruent, right? So if S is 93 degrees, what is M? Now, if I know that two of the angles in this triangle right here, one is 93, one is 63, do you have enough information to figure out angle L? Yes, let's do 93 plus 63 plus that missing angle measurement, I'll call it L for now, is equal to 180. And what do you get when you solve to get the missing angle measurement for L? Well, 93 plus 63 is going to be 156. Subtract 156 from 180, you get 24, right? So if angle L is 24, isn't angle R 24? Right? And it says 3x, so doesn't that mean 3x is equal to 24? Now I could solve for x by dividing by 3 on both sides. I get x is 8. Now that I know x is 8, I could plug that in here. This side length is saying 3 times x plus y. Well, 3 times 8, because I just found out x was 8, is 24, right? So that's like saying 24 plus y. Now, if you look at this side length, that's the length of SR, which starts with a green dot and ends in a red dot. Well, if you look at the other one where it starts with a green dot and ends in a red dot, doesn't it say it equals 43? So I'm going to set this equal to 43 to solve for y. And I would subtract 24 from both sides. What's 43 minus 24 going to give you? I believe it's 19, right? So that gives me x is 8 and y is 19. Okay? We have to be detectives. That's what's going to, you're going to have to solve questions like this on the test. You have to think about what's being given to you and what you could conclude based off what's given to you using the theorems that we've learned. All right, 3 is very much like the one we did already, which I'm not going to do another one like that right now. All right, find angle T. There's a theorem that we learned. First of all, do you see how both triangles, this angle A, oops, has this one little scoop mark and angle R has that one scoop mark? That means they're equivalent, right? Or they're congruent, right? So they're both 41 degrees. Then you could see that angle B has 2 scoop marks. Is there a 2 scoop mark in the other triangle? Which one? S. So that means those are congruent. So these are both 74, right? Now, the theorem we learned said that if you have 2 angle measurements that are the same, of 2 angle measurements of another triangle, that makes the 2 triangles congruent. That means that this missing angle for both of them is going to be the same, right? So with that being said, if I'm trying to find angle T, which is this angle right here, I definitely have enough information now. I would add 41 plus 74, right? And subtract it from 180. Oops. It's not the color I want. 41 plus 74 plus whatever angle T is 180. I'm not going to solve that. You guys could solve that for T, but that would give you T, right? All right. Number 1, I'm not doing. It's very much like the congruency statement we already did. All right, let's talk about 2. 2 gets challenging here. They're asking you for X, Y, and Z. Okay. Do you have enough information? There's different ways we could go about this. The first thing that I would say is if I wanted to solve for X right now, which is that degree, right? Do I have enough information to figure out X right now? Well, kind of no, but I could easily figure something out to say yes. Right now, how many angle measurements do you know of this triangle right here? No. How many angle measurements? Well, you're right. Sorry, it is 1. It is 1. We only know 1, 34, right? We need to know 2 to figure out the third. But using a theorem we've learned from the past, vertical angles, if this is 81 and it's across from this angle, doesn't that make that angle 31 as well? All right, I'm sorry, 81 as well? So now, do you have enough information to solve for X? Yes, let's solve for X by adding 34 plus 81. Right, and then do 180 minus that. And we get 65. So doesn't that mean X is equal to 65? Okay, that's fine. Z, now, really quickly, before I get to Z, this has one little scoop mark in this corner, and that says 34 degrees. If we look in the other triangle, we match it up with the one scoop mark. Doesn't that make that angle also 34? All right. Now, I do have enough information to solve for Z. What do you notice about this angle here, which we're calling Z, and this angle, which we just said was 34? What do you notice about those 2 angles put together? I couldn't hear you. What? They make a straight line, which means they add up to 180. So Z, whatever Z is, plus that angle that says 34 is equal to 180. Subtract 34 on both sides, and you get Z is equal to 146. So the last thing we have to do is figure out Y. Would you say that these 2 triangles are congruent to each other? Do all 3 angles add up to the same, or do all 3 angles, are they congruent? Yes, you have one angle, both both triangles have an angle that's 34, both triangles have an angle of 81, and both triangles have an angle of 65, right? So if they're congruent triangles, then we know that the sides are going to be the same as well. So if you look at this side length right here that says 6, it starts on this end with the 2 scoop marks. So if you go to the other side length here that starts with the 2 scoop marks and ends there, aren't those congruent pieces? So doesn't that automatically make y 6? So those are my 3 answers. X is 65, y is 6, z is 146. Number 3 is another congruency one where you got to show the different angles that are congruent. Yep. Those 2 sides are congruent to each other because we know the 2 triangles are congruent and those 2 side lengths are congruent. So this piece and the one in pink are congruent. All right, we're going to skip 3 for now. I told you not to even do 4. That one was definitely way too challenging. All right. Getting into the last lesson, we talked about 5.3. All right, this one we have to use that isosceles triangle theorems we learned. So this triangle has 2 equal sides, which makes it an isosceles triangle. What do we know is true about a triangle that has 2 equal sides? What do we know about the angles? All right, so when 2 sides of a triangle are the same, that means the 2 base angles are congruent as well. So if they're telling you that this angle measurement here, they're calling it x, I know that this is also the same, which I'll call x. And they're telling you that that obtuse angle is 130. So now I could set up my equation. I could say, okay, the angle that they gave me, which is 130, plus this angle measurement, which they're calling x, plus this angle measurement, which I know is also x because I know they're equal to each other, equals 180. And I would solve for x. X plus x is 2x. I would subtract 130 on both sides, and I would get 50. Oops, 2x equals 50. And then I would divide by 2 on both sides and get x equals 25. Sound about right? Number 2 is basically the complete opposite of number 1. Instead of telling me that 2 side lengths are congruent, they're telling me that 2... No, not lengths. They're not telling me necessarily that those 2 side lengths are congruent. The markings they're giving me are telling me that these 2 angle measurements are congruent, right? This is that converse of the theorem. Instead of me saying the 2 side lengths are congruent, therefore the 2 base angles are congruent, they're telling me the 2 base angles are congruent, therefore I know that the 2 side lengths are congruent. So since one of the side lengths is 3 times x plus 2, which I'd have to distribute and call that 3x plus 6, that's going to have to be equal to the other side length, which is 24. And now I could solve for x by subtracting 6 on both sides, so I get 3x equals 18. Divide by 3 on both sides, and I get what, x equals 6? I didn't really show my work there, but... Yeah. All right. 3 and 4 get challenging. I'm going to be honest. A question like number 3 is probably not going to... 4, maybe. 4, probably, but 3 is a little challenging. We're still going to do it, but it's not going to be on the test. Okay, but I still think you should pay attention because it's good to get in the habit of knowing how to piece by piece figure things out. All right, it's saying find x and y, right? The first thing I want you to notice is that there's a lot of triangles here, right? I want us to specifically look at the overall triangle, this triangle right here. What's one thing you could tell me about this overall triangle?
Equals 180.
All triangles equal 180, sure, but something's unique about this triangle. It's an equilateral because it's an equal angular. If it's equal angular, then it's an equilateral. So we know that all the sides are the same. With that being said, if they're telling me that this side is 46, doesn't that mean that this side here is also going to be 46? Right? And they're telling me from here to here is 16, And from this piece to this piece is y, so doesn't that mean if I do 16 plus y, it's going to equal 46? Right? So right away, I could solve for y by subtracting 16 on both sides, and I get y is 30. Are we good with that? Now, finding x is going to be a little bit more challenging. If you have an equilateral triangle, which that triangle I highlighted in red is an equilateral triangle, right? Or an equal angular triangle, right? Do I have enough information to figure out what, let's say, this angle measurement is? They're all 60, because if a triangle has 180 degrees and I know all three of the angles are equal, don't I do 180 divided by 3, which is 60? So that means each measurement here is 60. 60 here, 60 there. The problem is this one right here, if you look at this triangle, this whole piece, I'll do it in red, this whole piece is 60, right? But you could see that that has two different triangles or two different angles there. This one that I'm coloring in red and this one that I'm coloring in blue. Those two together equal 60. Do you agree with that? So if I want to figure out the one in blue, can I say 80 plus 60 plus whatever this is the one in blue? Or 80 plus 60 and then subtract it from 180. So 80 plus 60 is going to give me 140. So 180 minus 140, that means that this angle in blue is 40, right? So what is x then? If they're both, if added together it equals 60, doesn't 40 plus 20 equal 60? So that means that one's 20, which means x is 20. Make sense? Okay. You're not going to probably know what to do just the second you look at it. It takes a minute. If I have a student come up to me and ask me, how do I do this one? I have to look at it for about 15, 20 seconds to see the same thing I'm asking you to do. You have to think each one is different. You got to look at what you're being given, what you know, and what you could conclude based on what you know and work piece by piece. All right, this next one. Right away, my first thought would be, I see that this triangle is an equal angular, which means equilateral, right? Right? All the sides are the same. So that means that this side is 5y, this side is 5y, and this side is 5y, right? Doesn't that also mean this side is 5y since it has that same marking? The one that says 20. This piece right there, do you see how it has the same marking as this right here? Right? Those means those are equal. So if these are all equal, then doesn't that mean 5y equals 20? So right away, I could solve for y by saying 20 divided by 5 is 4. Okay? So that's y. To figure out x, do you see how these two sides are equal? Doesn't that mean these two base angles are equal? So I could call them both x, right? So x plus something is equal to 180. I have to figure out this angle measurement. Well, what do you notice about this angle and this angle added together? They equal 180, and we know this is an equal angular triangle, so doesn't that make this 60? So 60 plus what is 180? 120. So if this angle is 120, x plus 120 is 180, because that's what that final triangle has, x plus that one we just found out was 120. So I get 2x plus 120 is equal to 180. Subtract 120 on both sides, and I get 60. Divide by 2 on both sides, and I get 30. And there we go. That is my answer. Y is 4. Oops. And x is 30.
Can you give me 1 second?
Yep. If this right here is 1/2 x, so 1/2 x, and you can see these two sides are the same, doesn't that mean these two angles here are the same? So that the angle on the right is also 1/2 x, and this angle at the top is just 1x. Doesn't that all equal 180? What's a half of an x plus a half of an x? 1 whole x. So x plus x equals 180. What's x plus x? So 2x equals 180. And divide by 2, what is x? Right? Not nearly as difficult as it maybe looked. Anything divided by 2 means 1/2. Like if I said 10 divided by 2, doesn't that mean half of 10? Right?
When I was doing it last night, the only one that I had.
All right, so we went out of order, but number 1, you could see that those are the same, right? So doesn't that mean that this is 72 as well? Right? And these two are also the same. And you could see this marking right here. This little 1 scoop means that these two angles are the same. So if you have 72 in the bottom right corner, then this top left corner is also 72, right? Which means that this also has to be 72, right? Because the two sides are the same. So the two base angles are the same. So now we have enough information to solve for x. We say 72 plus x is 180, and we would solve for x. I'm gonna not solve for x, I'll let you do it, but that's how you would set it up. Number 3 you were asking about, I have to look at it myself for a second. So right away, I'm gonna say, I think I should, I don't know if I'm gonna need this or not, but I know I have enough information to figure out that missing angle right there, and I'm gonna do that to just give myself another possible clue, okay? So if I do 59 plus 90, I get what, 149? And then subtract that from 180, what is 180 minus 149? 31? Does that sound right? If I do 59 plus 90, and then subtract it from 180, I think I get 31, right? So this angle right here is 31. Would you agree with that? All right. I don't know if that's going to give us anything or not. It might, but let's figure this out. All right, here's what we could do. If this is 90 right here, let's look at this overall triangle, the entire triangle, right? The angle measurements of that entire triangle would be that 90-degree angle in the corner, plus this angle, which is 45. So 90 plus 45 plus whatever this whole angle is will give you 180. So I'll call that for now m, because I need a different variable, equals 180, right? And I end up with, I believe m ends up being 45 if you solve that. It does, because 45 plus 45 would be 90, and 90 plus 90 is 180, right? So this whole thing equals 45. Don't I subtract 31 to get x? Since we figured out this part of it is 31, I could say 45 minus 31 will give me, why am I blanking, 14? So x would equal 14 there. All right, the last one. Do you see how there are these right angles, right? Doesn't that mean this last piece would also be a right angle? That whole thing is going to be 90, right? Now, before I do anything, do you agree that this side of this figure and this side are going to be equal to each other? Those right angles prove that those two side lengths are equal to each other. Okay, so if this side is 24 and this side is 5y and 3y, if I add 5y plus 3y equals 24, right? I have enough information to figure out y, so 5y plus 3y is 8y. Divide by 8 on both sides and I get y is 3. If I know y is 3, what is 9 times 3 going to give me? So I'm going to replace this with 27. This whole thing is 27 plus 5, right? What is 27 plus 5? 32. So actually, I'll replace this entire thing with 32. All right. Now, if you look, this piece, this little sliver says it's x, this little sliver says it's x, and we know this sliver is 32, and don't we know the whole thing is 90? So we could say x plus 32 is equal to 90 and solve for x. Divide by 2 on both sides, and I get x equals 29, I want to say. again, these get somewhat intense. I would say you definitely need to know the basic ones for sure. We probably won't have the really challenging ones, but again, know what you're doing before you walk into the test, because it's gonna be a challenging test, okay?